You might have heard that everything is an object in Python. But what does that actually mean? Well, in today's video, we're going to figure that out and learn what it means for us as Python developers. Now, before we dive into today's video, I'd just like to thank Zed for sponsoring the channel. It's the code editor I've been using recently, and I've really been enjoying it. If you feel like trying out Zed, I've left a link in the description box down below where you can download it for free. Anyway, let's get back to the video. Let's start by learning what it takes to be an object. For something to be an object in Python, it must have an identity, a type, and a value. Even the simplest data types in Python have all three. For example, an integer in Python is an object, because it has an identity, a type, and a value. When you run this, you'll see all three. In other languages like C, 10 is a raw binary integer, which is quite strict. But in Python, 10 is an instance of the integer class, meaning we can directly call methods on it. Here, we need to use parentheses to make sure this isn't interpreted as a float. But as you can see, we can directly call the method on it here. And when we run this, we will get the bit length back of 64. And this dot notation is valid for any object in Python. How cool is that? Now, this is where things really become interesting. In Python, functions are objects as well, meaning you can treat them the same way as you treat a string or an integer. This means you can assign them to variables. As you can see here, we're assigning greet to say hello and then using say hello. This works. And it also means that we can pass them as arguments to other functions. And here I need to remember to import callable. But as you can see here, this function takes another function as an argument, and then we call it here. To run this function, we just need to call execute, pass in the function name along with the argument. And when we run it, we will get back hello James here. We can also store functions inside lists or other collection types. And finally, we can return them from other functions. And this is quite popular when querying or creating decorators in Python. Here we have a function which takes a setup, and then inside we return the multiply function, which means we can create other functions such as double and triple, and then we can use both of those accordingly. And as an output, we will get 200 and 300, because double doubles every number and triple triples every number. And again, these same rules apply here. A function has an ID, a type, and a value, which in this case is the function itself. Even modules and classes are objects in Python. If you decide to import math, it will have an ID, a type, and a value, which is the module itself and all its contents. Although, all of this might not be as exciting with classes because we're already used to treating them as objects. Like suppose we have a user class. We are well aware by now that we can instantiate it and create another object from it. All we're doing here is creating a unique object, since the user class is already an object. And again, this object has an ID, a type, and a value, which in this case is the instance itself with all the data it contains. But understanding what it means for everything to be an object is still something good to know about, because it really gives you a basic understanding of how everything can be used and accessed in Python. And there are no special rules for primitives here. Everything is an object which follows the same set of rules. And this also comes with great flexibility. Since functions, modules, and classes are objects, this means that Python also allows for highly flexible APIs, dynamic decorators, and powerful metaprogramming. Everything is an object and you are in control. A common example of where you'll see this being taken advantage of could be in some sort of command processor. For example, imagine you have a few functions that process text. One will lowercase the text, another will widen the text, and the last one will add quotes to the text. Since functions are objects, we can simplify this whole process by mapping string names directly to the function objects. And thanks to that little trick, we can now create a command processor which will take some input text and a pipeline. Inside, we will assign the value of input text to current text. And for each command in the pipeline, we will grab the command and try to apply it to our text. To do that, we will apply the current function to the current text and assign the result to the current text. Else, if the command doesn't exist, we'll state that the command was not found. And at the end of all of this, we will return the current text. Next, we'll create a string and create our pipeline, which will lower the text, widen the text, quote the text, and try to YOLO the text, which isn't a command, so that's not going to do anything. Below that, we will grab the result of processed text, and here we will pass in the raw data and the user commands. And finally, we will print the result. When we run our code, you'll notice that our text processor was able to call each function from the command registry, with the exception of YOLO, because that's just not a command. And the best part is that we won't have to touch this processor right here at all if we ever want to add new commands. We just have to add them to the command registry. This helps us avoid giant if-else chains along our journey, and allows for an easier way to scale our project with new commands. And that just about covers everything I wanted to talk about in today's video. Do let me know in the comment section down below if you learned something new today, but otherwise, with all that being said, thanks for watching and I'll see you in the next video.